6 is a nasty little guy. I think 8 you'll get mad. I think it's like 1 step or 2 steps. Yeah, it's really not much about 8. It really isn't. In this one here, notice how your denominator is a single term, your numerator has 2. Split it. When you have that scenario, a lot of times you want to split it apart to try and work with it.
Yes.
So 2 over secant minus secant squared over secant. Everybody okay with that?
Yeah.
Do you also agree that I can simplify the second fraction?
Yes.
Okay. If I simplify the second fraction, I get secant over 1.
Yeah.
Is it okay on that? Secant squared over secant is secant over 1.
No, back 1 step.
I split it apart.
How'd you do that?
Magic.
Oh, okay. No, I see what you did there. Okay, no mind.
See? You learned the magic. Now, at this point, I want you to notice what your result is supposed to be. Your result is in terms of sines and cosines. Right now, I'm in terms of inverse. So rewrite secant as cosine. So 2 over secant becomes 2 cosine. Secant over 1 becomes 1 over cosine. Football. This is 2 times 1 over secant, which is 2 times cosine. That's how I got it. Nope, because 2 is the constant. All right. Remember, 1 over secant is cosine. Secant over 1 is 1 over cosine. They're inverses of one another. Now, common denominator. And dun dun dun, 2 cosine squared minus 1 all over cosine. I'm almost there. I need to get the sine squared.
I flip it every time. I do like the cosine, 1 minus cosine on the bottom, and I'm like, how do you know? Do you multiply?
How do you rewrite cosine squared?
Sine squared.
Other way around.
Sine squared minus.
Other way around.
1 minus.
1 minus sine squared. So now you have 2 times 1 minus sine squared minus 1 over cosine, which is 2 minus 2 sine minus 1. So you get 1 minus 2 sine squared all over cosine.
Whoa.
No, I got lazy. There, I didn't get lazy.
Where'd the 2 come from?
Beginning of the problem.
What do you mean we're at the beginning of the
Might be.
2 never drops out early.
No, but what about, well, I thought we were in the sine part. Why is there 2 there?
Because it's 2 times cosine squared. I rewrote cosine squared as 1 minus sine squared. 2 is just a constant. It didn't go anywhere. It's still there.
Oh, okay.
All right. 7 and 8. Bless you. 7 is, 8's really easy if you go right to left. I'm not even going to bother with that. It's very, very easy. This is a prime candidate of doing conjugate. It's a prime candidate for conjugate. You have 1 over secant minus tangent. What's the conjugate of secant minus tangent? Doesn't that become a difference of squares? So I get secant squared minus tangent squared, which equals 1. Because 1 plus tangent squared is secant squared. So you have an identity there, and you get 1, and you're over here with secant plus tangent. And you're done. Yes, ma'am? Yeah. That's the reason we use them. Conjugates always use the difference of squares. Because remember, we want to get rid of the square root, we want to get rid of I. By doing that difference of squares, you're creating the positive values by getting rid of the I value and all that other junk. Get rid of roots and all that stuff.
Really stupid question, but why is secant squared minus tangent squared 1?
Because 1 plus tangent squared is secant squared. Test itself is basically, if you start thinking about what we've done, it's all non-calculator. It's mirrors what you did on those quizzes. Verify, simplify, general solution, and within 1 revolution. It's 2 questions of each. It's 12 questions. You have 48 minutes. 4, yeah.
I know I call myself as this bull.
Yes, ma'am. We're going to talk about that here in a second. I'll just remind you guys, that's general solution. General solution is when you have to tack on the revolution stuff. The within 1 revolution is what we were doing with the equations from last night. We're just listing them all out. General is when you have to figure out the repetition. So that's the subtle thing. Yes, ma'am.
Oh, is it mean 2 simplify and 2 verify, or is it 3 1 each?
2 simplify, 2 verify. Sir?
30.
3? Okay. 30. Oh, 30. Yeah, let's go into the work one then. 30. Was this the one where you wound up with sine of x equals 1/4?
Yes.
If you guys got sine of x equals 1/4, you did it just fine. Because what happens here, the other angle was 1, I think? -1. You're fine. Because you don't have a calculator, and you're not going to be able to find the sine value that has 1/4. You're okay. Tomorrow, everything's going to work out to something that goes on the circle. All right? Even the answer solution for the book here stops it at sine of x equals 1/4. So you did fine. Next year, you'll be able to find the sine value of 1/4. This year, you got to it, you're all right. Okay? You could use quadratic formula on these things, absolutely. I didn't give you any of those because I don't want you using calculators. Okay? There's a couple of them in this section, I think like 26, I think, with the cosines. You could use quadratic formula to get it, and then you have to bounce back into the 3rd quadrant for your obtuse angle. So you can do that next year. Next year? Trig is a lot. You have to have 3 years of math to graduate from high school. So, 3rd year of math is usually pre-calc or stats. Other than that, what else did you want to look at a different one in those from last night? From the where we had to do Pythagorean identity switcheroo?
Oh, it was.
Were they not that bad?
I thought it was 31.
Even better than
The verify simplify? Because there's an end in sight,
Crap.
usually. What's that?
I agree. Yeah, I did. Well, like, I didn't even, like, I tried to do this complex fraction, and it didn't seem to work out for me, probably because I was
It's a lot of little subtle things, and Trig's hard. It's hard. You know, it's tough, and that's why I haven't taken any of this stuff back for you guys, because I want you guys to keep seeing the relationship between different styles of problems and how similar they are, and what steps did you take? What do you have to use again? What do I have to use a conjugate? Am I going to try to break them apart to complex? Am I going to split it into 2 separate fractions? And am I going to go into sines and cosines? There are all these little tricks as you start to look at how the problem started, and, you know, especially with the verifying, you know where it's going to end. You get the idea of, what did I do? Oh, that's why, because this happened. And that's why I don't try not to take a lot of these problems from you guys, so you can continue to look at them. All right? Because this is hard. I'm not gonna lie, this is tough. Okay? And then on Monday we start graphing, which I think is easier.
Like graph
stuff for.
Yeah.
Like, do I graph on that really squiggly line, or?
Yeah, that is only other algebra 2 classes doing that.
It was worth a shot, yes. Yes, it was worth a shot. No, trigonometry basically doesn't have a calculator. So, all right. Let's do this then. Like I said with the problems, I want to remind you guys what it looks like to do general stuff.
I don't know.
Just you grab one too, did you?
It's not sure.
I thought you, for some reason I thought you had.
The time since is General source, general source.
Yeah.
Why?
Major pay, major pay.
I know.
Five points.
That's why we get practice fees.
Not a problem.
It's a staple.
So what I want to look at here is I kind of just cut and pasted a bunch of junk together, kind of give you guys an idea of some extra problems and whatnot. The first half of the front page kind of mirrors what you guys did on your quizzes. It mirrors how you set up and solve those problems from the quizzes. So remember, if you're trying to find the cosine value, what angle has a cosine value of -1/2, and the instructions say find the angle in terms of radians and degrees, think about what that means. Well, on my quiz, I had to place cosine within the correct quadrants to work. It had a boundary. It was between 0 and pi. Within those two quadrants, what quadrant did cosine become negative? Second. So that means that my adjacent is -1 and my hypotenuse is 2. What's the angle? 60. So this gives me my reference angle coming up, which means my correct angle is what? It's 120 and 1 radians. There you go. Fun. We got 4 minutes of problem. Hopefully you can do that one in 2.
That saves you 2 minutes on the problem.
No.
When you look at the sine value, remember sines are different. Your sine values are found between the first and fourth quadrants, between pi over 2, negative pi over 2. You can have negative angle with sine when you're doing these types for the quiz. So negative root 2 over 2 drops you down here at what angle? -45. The difference between something like this versus find the angle in an equation is that the angles in equations you're looking for positive revolution. And that's the difference. Yes, ma'am? Yeah, you can have negative. But remember, sine's pi over 2, negative pi over 2 excluding, because it's an asymptote. Remember tangent was open circle?
Oh, I didn't know.
Because you think about tangent, tangent's y over x, right? You divide by 0? That's y. Well, x is 0, but it's negative. General solution. Finding general solution. 5 cosine x minus root 3 equals 3 cosine of x. I'm going to solve for x with the general solution. You want to get x by itself, set aside equal to 0. What do I do to start?
Subtract the 3 cosines.
Okay, subtract 3 cosine x, and I have 2 cosine x. And I'm going to say that equals root 3. You okay with that? Just move that over?
Yeah.
What do I do with 2?
Divide by 2. Just divide by 2.
That's what I thought. So x is going to equal the inverse cosine of root 3 over 2. Now in this case here, you're looking for a positive cosine value of theta with the root 3 as your adjacent, 2 is your hypotenuse. What's the angle? 30 degrees. So the answer is going to be in pi, so it's pi over 6. And what other quadrant is cosine positive? So what's the angle?
So it would be pi over, 11 pi over 6.
So we're at pi over 6 and 11 pi over 6 for our 2 angles that works for this case. Are those 2 angles equidistant from one another as you're spinning around?
No.
Since they're not, you tack on. Okay? You tack on the 2 pi n. The absolute only time that you will ever have to worry about tacking on the pi over 2n was when? Do you remember?
Plus or minus
45's at all 4 quadrants.
Plus or minus 45, right?
Right. And if it was your pi over 4 in all 4 quadrants, that's the only time it's pi over 2 and repeating. Okay. Otherwise, if it's a, what do I think I had to-
I have a quick question.
Yeah.
In what quadrants is sign positive?
Which is what?
In what quadrants is sign positive?
What quadrant is y positive? So what quadrant is the sign positive?
Okay, no.
Same idea if I'm looking, the difference between that and an interval. Let's see here. Oh, we'll do the other, cosecant of x minus 2. This is still a general solution. Cosecant of x, or cosecant of x minus 2 is 0. General solution, add 2. So x is going to equal what angle has a cosecant value of 2? Well, cosecant's the inverse of what trig function?
Sine.
Sine is what over what?
Opposite.
Opposite over hypotenuse. So this is going to be hypotenuse over opposite,
Which is 30.
makes it 30. So it is at pi over 6. And now, Jenna, what quadrant was sine positive?
Second quadrant and the first quadrant.
So what quadrant is cosecant positive?
First quadrant and the fourth quadrant. Oh, cosecant. Oh, it's sine. Oh, the second quadrant.
I was setting you up for success there, and you failed me.
Oh, I know, but like, I don't know. I was originally get cosine and cosecant, so you get messed up because the C and then the S.
So it'll be 5 pi over 6. What is it? All students take calculus. All are positive, sine is positive, tangent's positive, cosine's positive.
Can you just say cast?
Or just remember your ordered pairs, x and y.
Cast. Catast.
Just remember what you said with
Just remember cosine is x, sine is y.
And for the other one was 11x.
Yes.
You know how like when
Yeah.
you like you get like between and then you take cosine.
Now, flip over to the back. And I want to show you the differences here.
Which one do you think? So this is
This is on the back. This is an interval. This is the solve on the interval, and you'll notice that it has a trigonometric Pythagorean identity thrown into it.
Oh yeah, I noticed that.
So, which one am I going to rewrite?
Sine squared.
In sine squareds.
I'm going to rewrite sine squared in terms of cosine squared, because I have a singular cosine, and I can't do anything with it. So by rewriting, this is kind of what the things we were doing a little bit yesterday, is that you take 4 times 1 minus cosine squared, plus the 4 cosine, minus 5. So you use those little Pythagorean identities every once in a while to switch them around to solve the equation. Distribute out and now I'm going to combine my like terms. The only thing I can do right here is 4 minus 5. What do you get?
1.
Yeah, you get the negative 1. So what happens here is you get negative 4 cosine squared of x plus 4 cosine of x minus 1 is 0. I'm still going to have to factor this, but what's the first thing I'm going to do?
Multiply by negative.
Multiply everything by the negative 1. Yeah, what you're saying, the GCF of negative 1 is fine. It's the same idea. All right. If you factor out a negative 1, all you're doing is change the signs and everything. That's what I just gave you. It's back page. So I'm going to change all these signs to become positive, negative, and positive. Now I can factor. So what times what is positive 4, but I add together to get negative 4?
I don't know. I think quadratic formula.
Negative 2 and negative 2. So I'm going to use the U substitution just because it's a little bit cleaner. And I go ahead and factor by grouping. Okay. When I group it out, I have 2u. I'm left with 2u minus 1. Take out a negative 1, and I have a 2u minus 1. Does it matter that I have the same term twice? Do I have to write it as that term squared? No. All I have to do is just still solve for u at one spot, and it's going to be fine. So we substitute back in our cosine. So you have 2 times the cosine value of x minus 1 is 0, which turns out to be what angle has the cosine value of 1/2. Cosine value is positive. Oops. Adjacent 1, hypotenuse 2, that means it's at 60. What's the radian value? Pi over 3. And cosine is also positive in the 4th quadrant, so its radian value is? Very good. And this is a 1 revolution, so all I have to do is just list it out, the angles. You don't have to tack anything on because you're bounded between 0, direction facing, to 2 pi. Okay? That's how that one works itself out.
Oh, Mr. Murphy, quick question. So if you were to say do the quadratic formula, would you have, and say that the 0 of negative 1/2, would you have to like do the opposite? Because that's saying u, like cosine equals negative 1/2, or did I mess up? Like, do you have to find the opposite, the inverse? If
You find you're solving up for your zeros, so your 0 would be 1/2.
okay.
So you said that the cosine, you find the cosine value of your 0.
Oh, okay, that makes
So
sense.
you're doing it fine. Yeah.
Okay, thank you.
So what else do you want to look at? You want to cruise through this? Is there specific? We got a few minute goes.
Did you just do one of the harder verify?
I don't know what would be considered a harder or easier
Take a
or
guess. How about we go with the last one? Last one's usually the
What
hardest.
about the,
number 7.
Kind of math goes.
I have to
Secant squared minus 1. Well, that's starting to look a whole lot like a Pythagorean thing.
Is it cotangent?
It's tangent.
So
So this becomes secant squared over tangent squared. So rewrite it in terms of sines and cosines. This is 1 over cosine squared times 1 over tangent squared. When I have 1 over tangent squared, what's that the same as? Cotangent squared. So I'm just going to do that real quick. What's cotangent squared in terms of sines and cosines?
Cosine squared over sine squared.
1 over cosine squared times cosine squared over sine squared. Da, da, da. 1 over sine squared is cosecant squared. And a pi 2.
you still have to practice.
Sure. So it's not as nasty as it looked. I had 2 terms in the denominator. I looked to see if it says it had a squared and a minus 1. I went through my Pythagorean identities to think, hey, is there something I can figure out there? Yay!
Since there's 2 problems about these, will there ever be a problem where you combine the complex fraction and the conjugate into one mega problem?
Oh, that would be awful, wouldn't it?
He's not going to change the test in one day.
Extra credit.
Don't doubt it. Don't
This is the
doubt
person
it.
who
Make it for extra credit, yeah, make it for extra credit. Like,
I do have a very challenging problem on the end of the test for you.
Extra credit.
no, he's gonna put in the one problem and everything else.
It was gonna be like an honors question that Seb had.
No. These aren't easy questions, guys. They're not.
We have to have it.
No. No, and if you leave other questions blank, I'm not even gonna bother even looking at it. All right?
That's the only one you did, right?
Oh, well.
Okay.
Yeah, 1 point.
Okay. Doesn't mean it's the answer.
We should all plan out that.
Eventually, sooner or later, maybe. Which
Which
one? On here?
Yeah.
On the side? Number 3 on this one. We have secant sine over tangent plus cotangent. Now, in this case, I've got multiplication in the numerator, and I have addition in the denominator, which means I'm going to want to write the denominator in terms of sines and cosines, because it's tangent, cotangent, and get a common denominator. Okay? I can make the top tangent, yeah. Does everybody see how secant times sine is sine over cosine?
Yeah.
I'll just leave it as sine and cosine. And the reason I'm doing that is because I'm putting all these in sines and cosines, and you'll see how it happens here real fast. This becomes sine over cosine plus cosine over sine. What's your common denominator? Cosine sine. So you have cosine sine times sine squared plus cosine squared, which is what?
1.
So now I have sine over cosine divided by 1 over cosine sine. So I just have to flip the bottom fraction as it's reciprocal, and things simplify out. And you get sine squared.
Wait, is that all?
Yeah, done.
Oh, wait.
Isn't that the same thing? All right, Val.
Oh, you just have to do the. I just had.
Because notice what happens. You have everybody see how it goes from multiplication to a subtraction, and that's some Pythagorean identity had to occur. All right. So what I would do is rewrite sine squared in terms of Pythagorean identity. What do you get? So this is tangent squared times 1 minus cosine squared. What do you do? Distribute. You get tangent squared minus, now I'm just going to do this real quick, sine squared over cosine squared times cosine squared. Okay.
So you say the problems are hard. Are they harder than this?
I don't think so.
Oh, then okay.
What's up?
So, are the ones, are these ones like all the formulas that we know, or they're,
Did we ever do negative angle?
no?
No.
Oh,
No, just, is there ones that aren't here?
Do you remember the sheet that I gave you?
Mm-hmm.
That sheet that I gave you. Do you have that sheet that I gave you?
Probably in there.
The pile of mess.
I never throw anything out, so.
Well,
it's
good luck
there.
finding it.
I can navigate through it.
I don't know what page it is. 14. Yes, ma'am. Same stuff. Oh, you're gonna kill yourself.
She shot like 6 at.
Secant over cosine. If I bring the cosine up, what do I get?
cosine squared.
I get secant squared.
Dang it.
Tangent over cotangent. If I bring cotangent up, I get.
Cotangent. Keep wanting to put tangent down.
I did it a complete
problem.
That sucks for you, Val.
That's all it is.
No problem.
You're done with Val.
Okay.
Actually learned her
All
name.
right. When you're multiplying inverses together, they drop out. When you're dividing the inverses, they square each other.
What do you then see? Recreational thing.
Back page, the third one. What do you think? Should I rewrite sines or rewrite cosines? Does it matter?
Flip a coin.
Doesn't matter. I'm going to rewrite the sine squares. Okay? Because then I can just bring it over to the left. Is it okay with that?
Yes.
All right. So we have 3 cosine squared of x is 1 minus cosine squared of x. Write this down, man. Move the stuff over. Oh, sorry. What's 3 cosine squared plus cosine squared?
Cosine squared.
What do I do before? And then what do you do? Take the square root. So what angle has a cosine value of plus or minus 1/2?
60. Sorry. I'm doing
Cosine value of 1 over 2, so that's got to be my 60. So it's pi over 3. Now this is looking for plus minus, and it's saying within 1 revolution. So do I do tack on ends, or do I list them all? List them. So reference angle, pi over 3 gives me 2 pi over 3, 4 pi over 3, 5 pi over 3. So in this case, there are 4 possible angles that work.
How do the other angles work because the one is, oh, it's plus.
Plus, that's the square root. It's a very, very simple thing to forget. Don't forget when you take square roots over equal signs, plus minus. Yes, ma'am.
So how can we link to the higher rate plus pi?
It's bounded within 1 revolution.
Oh,
If you look at the very top of the page, it says solve for x within 0 is less or equal to x, less or equal to 2 pi.
it's has the n tacked on to the key n number.
Correct. That's general, because there's an n in general.
So we don't have to do that out.
Yep. It'll specifically say solve for x, find the general solution. Yes, sir.
Will there be any problems that won't be like more than 0, less than 2 pi?
Nope, because that's how we've always done it. Why change it now? Yes. Yeah, because you're between 0 and 2 pi. Yeah.
Yeah.
Yep. Exactly right. Okay. What else can I look at?
I think we're dandy.
Hmm?
I think we're dandy. I use jargon from the 50s now.
You guys are doing fine. Trust me, you know what you're doing. Know your identity. You'll be all
I
right.
have no trust in myself. Just like I don't trust those dirty counties.
Or is that tomorrow? There's no flex tomorrow.
We have to.